What if the sun became a black hole? Imagine waking up tomorrow to find the sun gone. No blinding rays breaking over the horizon, no warmth on your skin, just a black void where the center of our solar system used to shine. But then, something stranger. Earth keeps orbiting. The planets continue circling as if nothing happened. The invisible force holding us in place is still there. Only now, it's coming from something far more terrifying. A black hole. It's one of the most haunting what-ifs in science. What if our sun suddenly collapsed into a black hole? Would we be torn apart instantly? Would Earth be swallowed whole? Or would life continue in ways we can hardly imagine? To understand our nightmare scenario, we need to step back and ask a deceptively simple question. What is a black hole? At first glance, it sounds like science fiction, a cosmic vacuum cleaner sucking up everything in sight. But the truth is stranger and far more fascinating. A black hole is not an object in the traditional sense. It's a region of space where gravity has become so powerful, so overwhelming, that the very fabric of space and time bends in on itself. Inside this region, escape becomes impossible. Not for planets, not for stars, not even for light, the fastest traveler in the universe. At the heart of a black hole lies what physicists call a singularity, a point of infinite density. Imagine taking a star dozens of times the mass of our sun and crushing it into something smaller than a city. At that singularity, our most trusted laws of physics, the ones written by Einstein and Newton, simply fail. Surrounding the singularity is an invisible boundary known as the event horizon. Think of it as the ultimate point of no return. Cross it and you're gone forever. No rocket can escape. No signal can be sent. From the outside, anything that crosses the horizon appears to freeze in time, stretched and distorted by gravity's pull. Now here's the twist. Not every star can become a black hole. In fact, our sun will never become one. Why? Because mass is destiny. To collapse into a black hole, a star must be at least 20-25 times more massive than the sun. These giants burn hot, live fast, and die young. When their fuel runs out, they collapse under their own gravity and explode in a titanic event, a supernova. Our sun, by contrast, is too small, too steady, too ordinary. In about 5 billion years, it will expand into a red giant, swallowing Mercury and Venus. Then, in a quiet sigh rather than a cosmic scream, it will shed its outer layers, leaving behind a faint, glowing ember, a white dwarf. Let's imagine the impossible. Overnight, the sun collapses into a black hole with the exact same mass it has today, 1.989 x 1030 kilograms. The black hole would be tiny, about 6 kilometers wide. To put that into perspective, that's smaller than the average city. All the light and heat we depend on would vanish instantly. Earth would be plunged into absolute darkness. At first, the sky would still glow faintly. We'd see stars, the moon reflecting nothing, and the ghostly afterglow of sunlight already en route to Earth. Remember, light takes 8 minutes and 20 seconds to reach us. That means humanity would have just over 8 minutes of normal daylight before eternal night fell. Here's where science bends our expectations. Most people think a black hole would immediately swallow Earth, but it wouldn't. The sun's gravity doesn't come from its light or heat, it comes from its mass. If that same mass were compressed into a black hole, the gravitational pull on Earth would remain exactly the same. That means Earth would continue orbiting year after year as if nothing had changed. No spiraling into the abyss, no instant collapse, just endless night. It's a counterintuitive truth that reveals something profound about black holes. They're not cosmic vacuums sucking everything in. They only dominate what strays too close, inside their event horizon. For our hypothetical sun black hole, that horizon would be only 3 kilometers from the center. Earth, 150 million kilometers away, would be perfectly safe, gravitationally speaking. But safe doesn't mean survivable. Without sunlight, Earth would face a cascade of doomsday changes. Within a week, global surface temperatures would plummet below freezing. Within a year, oceans would start freezing solid from the top down. Plants, starved of photosynthesis, would die. Animals, depending on them, would follow. Humanity would be left scavenging dwindling food supplies. The planet would transform into a frozen wasteland, illuminated only by distant starlight. Yet not all hope would be lost. Deep below the oceans, hydrothermal vents powered by Earth's inner heat could sustain life for millions of years. Extremophile organisms, tiny creatures that thrive without sunlight, would carry on. In a strange way, Earth wouldn't be entirely dead, just drastically quieter. And what about the view above? Instead of a blazing yellow star, we'd see nothing. The black hole would be invisible against the cosmic background. Only its gravitational warping of light would give it away. Stars behind it would appear to bend, twist, and smear into strange arcs, like a cosmic mirage. Astronomers call this gravitational lensing one of the most breathtaking predictions of Einstein's general relativity. In the night sky, a perfect circle of distorted starlight, known as the Einstein ring, would reveal the sun's new terrifying identity. Could we survive such a cosmic disaster? Some scientists speculate humanity might retreat underground, building vast geothermal-powered cities. Nuclear reactors and fusion experiments could replace the lost sunlight. Farming would shift indoors under artificial lamps. But long-term survival would be uncertain. Earth would drift further into deep freeze, and resources would dwindle. Our only real hope might be leaving Earth entirely, finding refuge on another world, orbiting a living star. In other words, if the sun became a black hole, it wouldn't instantly kill us, but it would start a slow countdown to extinction. But here's a twist. What if the sun didn't collapse quietly into a black hole of equal mass, but instead went through a realistic collapse? In that scenario, it wouldn't just vanish. The sun would explode as a supernova first, blasting Earth with deadly radiation, stripping away our atmosphere, and possibly ejecting us entirely from orbit. In fact, Earth might not survive long enough to even face the black hole. Another unsettling thought: what if a rogue black hole, formed elsewhere in the galaxy, wandered into our solar system? Unlike our sun's peaceful replacement, a passing black hole could tear planets from their orbits, slingshot worlds into interstellar space, or swallow them whole. Astronomers believe there could be 100 million black holes drifting through our Milky Way right now. Most are invisible, undetected, and some may be closer than we think. So what if the sun became a black hole? In one sense, nothing would change. Our planet would keep orbiting, locked in the same gravitational dance as always, but in every other sense, everything would change. No light, no warmth, no life as we know it. It's a paradox, a universe where Earth is safe, but doomed. And perhaps that's the deeper lesson here. Our fragile existence depends not just on gravity, but on light, on warmth, on the balance of forces that give us oceans, air, and time to dream. The sun is more than just a star. It's the heartbeat of our world. And imagining its death reminds us how astonishing and how precarious our own survival really is. So tonight, when the sun sets and you see its last rays vanish behind the horizon, ask yourself, what would you do if those rays never came back?